So in number 10, we want to find the cost x and y value, which make this cost minimum. In this case, the volume is fixed. So when you think of this rectangular tank, the base is square and depth is y, so that means the volume is x squared times y. And that's equal to 1125. So we can change this xy in terms of x. So xy is equal to 1125 divided by x. So that means the cost is let's first open the parentheses. So that means 5x squared plus 30xy. So if we make this substitution, like this, and then let's factor 5 out, like this. Yep, and then find the first derivative. Yep, so what's the derivative of x squared?
2x.
2x, and then for this one, this is kind of x to the minus first power, so we can make this type of derivative. And then to be minimum, this first derivative should be 0. So when this parenthesis should be 0, that means x cubed is the half of this 6750. That means 3375. Yep, so x is the cube root of this. Can you find this value using calculator? Can you find cube root in your calculator?
Mhm.
Okay.
15. 15.
15. X is 15, and then if x is 15, y is the this one divided by x squared. Yeah. So what's the y value when x is 15? Or is this? Oh, let me think. Oh, yeah. So that means y is 100. 1025 divided by 225. That means it's 5. Yeah, so when x is 15 feet and y is 5 feet, that will make the total cost minimum. And this cost is composed of two parts. This one is used for the making the tank, and this one is used to make the excavation. And yeah. So that's why the total cost is the sum of these two. Yeah. And so if I explain more, the unit cost for making the material is $5 per per square feet. Am I right? And for the excavation, it'll cost $10 to make 1 square feet area, 1 square foot area. And let's think of designing a poster. So when you make a poster, rectangular poster like this, and you want to make some margin, 4 inches top and bottom, and 2 inches at each side. So the original size is 50 square inches. So let's say this is width and length. So width times length is 50, and the total size will be W plus 4 and L plus 8, including the margin. So if we make the open the parenthesis, and because WL is 50, we can add these two. Um, and then let's change L to 50 over W. That makes like this. Yep, and then if we make the derivative, so 8W is 8 when the derivative. What's the derivative of this second term? 200 over W. This one. We just did a similar one like this. What's the derivative of this? So minus 1 comes out, and then the due exponent is minus 2. So like this. And this derivative should be 0. That means uh, with the squared is 25. The width is 5. So when width is 5, what's the length? Yeah, when
Um,
5 length is
2. Oh,
10,
sorry.
10. Yeah, to make 50, 10. And then what's the overall dimension? Overall dimension means what's the total width if inside the width is 5, if you include these margins.
Um,
Yeah, 2 and 2, so that means
14.
okay, so 9. I mean 5 and 2 and 2 makes this 9, the overall
Oh, that
width.
was
Okay, and what's the overall length?
overall length.
Yep,
Four- uh, mm, 18.
yep, 18. So that's the overall dimension, 9 and 18. How about this cone inside the sphere, we want to make the volume of the cone largest possible. So we can first make the Pythagorean theorem. The x squared plus y squared is this 3 squared. And for the volume of the cone, and the height of the cone is 3 plus y. So we can change this x squared to 9 minus y squared. And then we can open the parentheses. Like this. And then let's make a derivative. So 27 disappears and 9y's derivative is 9. What's the derivative of this 30y squared? Can you find the derivative of this 3y squared? Oh yeah, 3 times y squared. What's the derivative?
Y?
Yeah, 6y. And then how about this y cubed? What's the derivative of y cubed?
3y squared.
3y squared. Yeah. And then this derivative should be 0. That means this inside parenthesis should be 0. So yeah, if we make the factoring, y is minus 3 or 1, but minus 3 doesn't make sense. So y should be 1. So when y is 1, and the volume is, we can use this one. So the maximum volume is 32 pi over 3 is the maximum volume. So when y is 1, the radius of the cone is 2 times the square root of 2. So when we make a circular cylindrical cone, to make the circle from the square, I mean the aluminum shape is a square instead of a circle. So after cutting the circle, there will be some leftover. So in this situation, we want to find and the material a minimum. So at first the volume is fixed. So that's 1000. And to make this area smallest, so now we are using this one instead of this because the aluminum shape is square. So when we derivatize this area, Yeah, what's the derivative of this a times r squared? Uh, but before that, let's change this pi r h in terms of r. This pi r h, pi r h. Yep, we can change this second term using this volume. And then let's make a derivative. So now, what's the derivative of a times r squared? Can you hear me? Can you make the derivative of this one?
16.
Yeah, 16r. How about second term? Can you find the derivative of a second term?
Hmm?
I think like this, like this.
Yeah. 2000 r over r squared.
You're right. Yes. So that's the first derivative, and this should be 0. That means r cubed is. Let's simplify this first. That's 125. So now what is r? Value of r? Uh, uh, can you find the cube root of 125?
Hmm?
Yeah. Can you find
5.
5? Yeah. Radius is 5. So when the radius is 5, h, the height is mm, 1000 divided by 25 pi. So that means 40 over pi is the height. And in this case, the ratio of h to r, uh, that's 8 over pi. Okay. So it's the ratio is a little greater than more than this 2 to 1 because pi is 3.14, but 8 is more than 2 times pi. So uh, in this case, we need to make a little taller the cylindrical can. Um, if we take the leftover into account. And let's um, think of making this suitcase. After folding this paper, uh, make these margins, and then when you open the paper, we will have this net, and the central rectangle is the base. And when you fold, the box shape will be made. So this means now the base, after opening this fold, this has 2x, and this part is the 18 minus 2x, and for this, uh, that's 24 minus 2x. And that means when we multiply these three, that will make the volume of this suitcase. So let's take 2 each from each parenthesis. That means, and if we open the parenthesis, if this comes out, and if we make the derivative of this, to have the maximum volume, the derivative is 0. That means, so if we solve this equation, for the domain, it should be this minus square root of 13 plus big makes the margin 2 greater. And so when x has this value, that will make the maximum volume. Mm, so let's make a graph of this and to see if this makes really the maximum volume. Yeah. Yeah, maximum occurs when x is 3.4. So if we make estimate this is 7 minus square root of 13. Yeah, that's also this 3.39. That's this point. And so when margin is about 3.4, the maximum volume is about 1310 square inches. Yeah. Yep, I think that's enough for today. So let's meet tomorrow at 7 for AMC.
Okay, bye. Have a good
Yeah,
day.
have a good day. Yeah, bye.